So here we have a cable wiring nightmare. If you've never seen one before, at some point in your career you will see something. Now, while this picture may be a little bit overkill, I did search for cable wiring diagram. There's some better options out there. But as you can see, I mean these are real images, of real network operations centers. It's not ideal to see this type of stuff. You generally want to look at something that's a little more pleasing and it has good cable management, right? So these cables are running through cable raceways and they're really well done. But one of the things that could happen in this situation is that what if we were to plug something into itself, like a switch, right? And so what would happen? And while this is not the purpose of spanning tree protocol, which is where we are in Module 5, it is one of the benefits of having spanning tree protocol running on a switch, is that if I do plug the switch into itself, the answer, what happens when you plug the switch into itself? Nothing. And in the case where I have spanning tree protocol on, that is true. But in the case where I have a switch that does not have spanning tree protocol, what I will get is a layer 2 loop. And here's an example of that loop. Is the packet goes out from all the switch ports, right? And essentially what we end up getting is a problem where the packet bounces between the switch port and thus it eventually overwhelms that switch. Now, there are situations where you will find switches that don't have spanning tree protocol on them. They're lower grade switches. Most of your routers, the consumer grade routers that you get that are internet facing, they do not have the spanning tree protocol running on them. So it's very easy to get a routing loop where the router just shuts down. I'm sorry, a layer 2 loop, sorry, where the switch just shut down. So that can happen. And so if you ever have a situation where you're dealing with a customer and all of a sudden, I rebooted so here's what will happen is they'll say, well, I restarted my router. And all routers have a layer 2 switch on them in the consumer grade anyway, where they may have 4 ports as a switch port. Here's an example of one. Linksys. This is a very common router. Okay, so it's a consumer grade device. There's a 4-port switch on the back of this thing. So a common mistake. User calls in and says, I just restarted my wireless router, and it worked for a little while, and then it just stops. And I restarted again, and then it worked for a little bit, and then it just stops. And I do this over and over again. I don't know why. And so what you do in troubleshooting this is you start to go, okay, well, let's look at the cables and let's trace them and let's see where those cables go. Right? So we start to trace the wires. What we end up finding out, maybe, is that the cable we trace one cable and then we end up going right back to the next switch port on that switch. So in this particular case, these little routers, they don't have the spanning tree protocol enabled, so they can easily fall victim to layer 2 loops. Right, and so there's that idea, that big data center, we don't know where things are going, what's plugged into what. Right, that's a very big possibility. And so being able to have spanning tree protocol, if I have this done properly, and I have a Cisco switch running spanning tree, and I plug a port into itself, what happens? Nothing. Okay, that's what we want. But spanning tree protocol was designed so that we could have redundancy, right? We needed to figure out a way to basically self-diagnose and handle layer 2 loops and create redundancy in networks, because it's much better to have uh, a port that I can use that I can turn on when needed. Now, in this particular case, this is a spanning tree protocol network, and so you can see that these switches are redundant. And what happens is that the spanning tree protocol goes and it actually blocks the port. Now we see this red arrow with a red note, and just note that is not disabling the port. It is not off. It is definitely blocked. Right? So what would happen is, and so what that means is that there's not a circular path in this network. If we didn't block this port right here, there would end up being a circular path, and we could continually pass objects around that circle until one of the switches just gave out. And at that point, everything would probably work right. So anyway, here we are in this scenario, and we want to use redundant cables. What happens if I have a cable cut, right? If a rat chews through something or something slices through a wire, I want to be able to use redundancy in my physical network. Right, so that's where we are in the physical side, and we're going to take a really detailed view and drill down and figure out how this thing really works. And you may have to go through and kind of watch the next video a couple times because it is a little bit detailed. But once you figure out how this spanning tree algorithm works, you're going to be able to get it right in your head and go, oh yeah, okay, I see what's really happening here. There is nothing happening by chance. It's all happening in a very straightforward way. I'm going to show you how this process works, and we're going to go straight through it, and you will have a better understanding of it when you're done.